A. Maximum frequency. The maximum frequency of X-rays produced by an electron is given by the equation nu equals A h, where nu is the frequency of the X-ray in Hz. A is the energy of the electron in eV. H is Planck's constant, which is 6.626 times 10 to the minus 34 Js. The energy of an electron is given by the equation A equals QV, where A is the energy of the electron in eV. Q is the charge of an electron, which is 1.602 times 10 to the minus 19 CV is the potential difference in volts. In this case, the potential difference is 30 kilovolts, so we have A equals 1.602 times 10 to the minus 19 C times 30,000 volts equals 4.806 times 10 to the minus 15 J. Converting this to eV, we get A equals 4.806 times 10 to the minus 15 J times 1 eV. 1.602 times 10 to the minus 19 J equals 30,000 electron volts. Now we can plug this value of A into the first equation to find the frequency. Nu equals 30,000 electron volts, 6.626 times 10 to the minus 34 Js equals 7.24 times 10 to the 18 Hz. Therefore, the maximum frequency of X-rays produced by 30 kilovolts electrons is 7.24 times 10 to the 18 Hz. B. Minimum wavelength. The minimum wavelength of X-rays produced by an electron is given by the equation lambda equals hc E, where lambda is the wavelength of the X-ray in meters. H is Planck's constant, which is 6.626 times 10 to the minus 34 Js. C is the speed of light, which is 2.998 times 10 to the 8 meters per second. A is the energy of the electron in eV. In this case, we have already calculated the energy of the electron to be 30,000 electron volts. Plugging this value into the equation above, we get lambda equals 6.626 times 10 to the minus 34 Js times 2.998 times 10 to the 8 meters per second, 30,000 electron volts times 1.602 times 10 to the minus 19 J per electron volt equals 4.14 times 10 to the minus 10 meters. Converting this to nanometers, we get lambda equals 4.14 times 10 to the minus 10 meters times 1 nanometer, 10 to the power of minus 9 m, equals 0.414 nanometers. Therefore, the minimum wavelength of X-rays produced by 30 kilovolts electrons is 0.414 nanometers.